Picture this. Your next commute could be hands-free, crash-free, and, if the chip makers are to be believed, traffic jam-free. Imagine pulling out of your driveway, sinking into the seat, and watching as your car handles the gridlock, the merges, even the surprise lane closures, all while you catch up on emails or simply enjoy the silence. In 2025, the hardware nestled beneath the hood is smarter than the driver ever could be, not just in raw processing power, but in its ability to perceive, predict, and react with superhuman speed and precision. Stick around because in the next few minutes, I'll take you through the 3 monumental breakthroughs that have flipped science fiction into the reality parked in your garage, transforming not only how we drive but how we live. And this isn't a distant dream. The revolution is already here, happening now. Hey everyone, I'm Alex, and welcome back to the channel, where we do more than just read spec sheets. We break them down into street talk. Real-world impact you can feel, see, and eventually experience from the passenger seat. Today, we're diving headfirst into the fascinating world of silicon, hypersensitive sensors, and groundbreaking software stacks that empower production cars to make split-second decisions. When to hit the brakes, when to overtake with confidence, and when to guide you to your next exit, all without you having to lift a finger. This isn't about basic driver assist anymore. This is true autonomy. By the time we wrap up, you'll know exactly what's just marketing noise, what's here right now, and what's coming soon to your dealership. Get ready because the future of driving isn't arriving. It's practically parked in your driveway. AI chips, the 1,000-watt brain. Our first monumental breakthrough, the one making all of this possible, is nothing short of a brain transplant for your car. For years, autonomous driving struggled with processing power. We simply couldn't cram enough intelligence into a car to handle the enormous amount of data in real time. But that's changed, and it's changed in a big way. Take NVIDIA's new Thor SoC, for instance. This isn't just a powerful chip, it's an entire supercomputer condensed onto a single die, with an astonishing 770 billion transistors. Let that number sink in for a moment. To put it in perspective, that's more computational muscle than some data centers had just a few years ago. What does this mean for you and your commute? It means this chip can effortlessly process a staggering terabyte of raw camera, radar, and LiDAR data every hour. Imagine the complexity of processing every pixel, every radar ping, every LiDAR point from multiple sensors all at once, and then making sense of it. It tracks pedestrians, predicts vehicle movements, understands traffic signals, and navigates intersections, all with ease. A terabyte of data every 60 minutes, handled without breaking a sweat, while sipping just 150 watts of power. That's half the energy consumption of last year's top-tier chips, a critical factor when you consider the limited power budget of electric vehicles. It's not just about speed, it's about efficiency at an unimaginable scale. But NVIDIA isn't alone. Qualcomm's Snapdragon Ride Flex platform is taking things even further with its cutting-edge 4-nanometer manufacturing process. This isn't a minor tweak, it's a generational leap in miniaturization and power efficiency. The result? A chip so compact and efficient it can fit behind your glove box, leaving just enough room for your takeout noodles, as engineers joke. The fact that such powerful brain power fits in such a small space speaks volumes about the relentless innovation in chip design. And here's the kicker: safety. Both of these chips feature fail operational mode, which means the car will keep running even if a component fails. Think of it like a co-pilot who's always ready to take over. If one core fails, a twin core takes over in less time than it takes for you to blink. This seamless transition ensures that the car never panics, never loses its composure, and never compromises safety. This redundancy is why industry leaders like Mercedes-Benz have successfully received regulatory clearance for Level 3 eyes-off driving on Germany's Autobahns. Yes, you can legally take your hands off the wheel, knowing your car has layers of computational safety working beneath the surface. So, the bottom line for 2025? This is the year that a car on the showroom floor has more computational power than a modern fighter jet. Think about that. A fighter jet, built for complex maneuvers and calculations, now has less brain power than your family sedan. And it does it all without draining the battery, thanks to advancements in energy efficiency. This isn't just making cars smarter, it's redefining what a vehicle is capable of. It's about creating a machine that perceives, understands, and reacts with a level of sophistication that was once the realm of science fiction. The brain transplant is done, and our cars are now geniuses. Sensors, cheaper, sharper, everywhere. If the AI chips are the brain, then the second breakthrough is all about giving our cars superhuman senses. For autonomous vehicles to truly navigate the unpredictable world around us, they need to see, hear, and even feel their surroundings with unparalleled clarity and consistency. And in 2025, those senses have not only become sharper, but have become dramatically more affordable and ubiquitous. Let's start with LiDAR. Not too long ago, LiDAR units were bulky, fragile, and ridiculously expensive, often running into tens of thousands of dollars. They were reserved for research vehicles and high-end prototypes. But things have changed, and solid-state LiDAR is here. This revolutionary technology eliminates moving parts and has slashed prices by an astonishing 90% in just 2 years. What used to cost $2,500 is now available for a mere $250. This isn't just a discount, it's a game changer. LiDAR is no longer an exotic, niche technology. It's now affordable for mass production, meaning automakers can integrate it into a wide range of vehicles. But LiDAR isn't the only sense getting an upgrade. Let's talk about radar, specifically 4D imaging radar. Traditional radar could only measure distance and speed, but 4D radar adds 2 more dimensions: elevation and velocity. What does this mean for you? It means your car can now see through adverse weather conditions like fog, rain, or snow, where cameras and even LiDAR struggle. It can also read elevation changes with incredible accuracy, spotting stalled vehicles long before you even reach them. This proactive perception can help prevent accidents caused by poor visibility or unexpected obstacles. There's a fascinating divergence in the approaches to sensing. Tesla, for instance, has stuck to a pure vision strategy, relying almost entirely on high-resolution cameras and sophisticated AI to interpret the world, just like a human driver. It's an ambitious strategy, but nearly every other automaker has chosen a fused buffet approach, combining multiple sensors. This includes cameras, radars, LiDAR, and ultrasonic sensors to create a robust, redundant perception system. The result? A far more reliable, flexible, and safe system that can handle almost any scenario. Consider Huawei's claim that their sensor fusion system can spot a fallen motorcycle at 150 meters, even in a dust storm, with 99.97% confidence. This is the power of sensor fusion, combining multiple types of perception to create a detailed, nuanced, and robust understanding of the car's environment. And what's truly remarkable is the cost. When these sensors, cameras, radars, and solid-state LiDARs become mass-produced, they're no longer just available for high-end luxury vehicles. They're going into mid-tier sedans and hatchbacks, democratizing advanced autonomous features and making them accessible to a far wider audience. The car's senses aren't just sharper, they're everywhere, making our roads safer for everyone. Software, the end-to-end neural takeover. If we've given our cars a powerful brain and superhuman senses, the third breakthrough is about giving them a truly intelligent cortex, the software that processes all that sensory input and translates it into seamless, safe driving decisions. This isn't just about better code, it's a reimagining of how autonomous systems are built. In the early days of autonomous driving, cars were programmed with if-then rules. If the pedestrian is here, brake this much. If the light is green and no cars are in the intersection, accelerate. This approach was brittle because it couldn't handle unforeseen situations, those pesky edge cases. But today, that approach has been completely replaced. Now, we have a single, elegant end-to-end neural network that processes raw pixels and sensor data to directly produce steering angles, acceleration, and braking decisions. Instead of relying on explicit rules, AI learns from vast amounts of real-world driving data, just like humans learn to drive. Waymo, for example, didn't just train its AI with real-world miles, it trained it on a staggering 20 billion synthetic miles. How? By using NVIDIA's Omniverse, a platform that simulates virtual worlds with hyper-accurate physics. This isn't just a game. It's a digital twin of the real world, where the AI experiences rare, dangerous edge cases, like kangaroos crossing the road or shopping carts tumbling into traffic. Synthetic data allows developers to stress test AI systems against every conceivable scenario, making them incredibly safe and reliable. And here's where generative AI, Gen AI, comes in. Startups like Haumo AI are using Gen AI to intelligently generate diverse training data, cutting the cost of training their models by 70%. This results in dramatic improvements in reliability, with disengagements, those moments when a human takes over, dropping to just once every 5,500 miles. This is a staggering improvement and points to a system that's becoming incredibly robust. The real game changer is over-the-air, OTA updates. Forget buying a new car every few years for the latest features. Your 2025 EV could wake up next month with entirely new capabilities like citywide Level 4 autonomy, all while you're sound asleep. Your car isn't just a vehicle, it's an evolving platform that gets smarter over time, continually gaining new features and improving its performance. The end-to-end neural takeover is here, and it's constantly learning, improving, and evolving. If you're as fascinated as I am by these incredible advancements, and you want me to put these cars to the test on real roads, pushing their boundaries, then you have to hit that like button. Seriously, smash it. That tells YouTube you're here for more than just pretty dashboards and glossy marketing. And while you're at it, drop a comment below. Which brand do you trust enough to let take the wheel first? Mercedes, Waymo, or maybe a bold newcomer? Let me know. Levels of autonomy. What you can buy today. Now let's get down to what all this tech actually means for you, the driver. What's available right now? Let's talk about it in terms of the official levels of autonomy. Level 2 Plus, also known as Level 2 Plus or Enhanced Level 2, is now the baseline. It's expected in nearly every modern premium vehicle. This isn't just adaptive cruise control, it's integrated lane keeping and autonomous lane changes. Just tap the turn signal and the car checks its blind spot and moves smoothly into the next lane. It's a fantastic feature for long highway drives, reducing driver fatigue. But remember, this is still Level 2. You, the driver, are always in control, ready to take over at any time. Level 3, though, is where things start to get interesting. Here, the car can genuinely drive itself in specific situations, and you're legally allowed to take your eyes off the road. The Honda Legend in Japan and the Mercedes-Benz EQS in certain U.S. states offer Level 3 traffic jam chauffeurs that handle stop-and-go traffic up to speeds of around 40 mph. You can relax, read, watch a video, whatever you want, while the car does the driving. But there's a catch. The system will issue a takeover request if it encounters a situation it can't handle, and you must be ready to take control within seconds. Level 3 gives you true autonomy, but it's still conditional. Next, we have Level 4, which is where true driverless driving starts to emerge. These are robo-taxis that operate without a human safety driver behind the wheel. Companies like GM's Cruise Origin and Baidu's Apollo Go are already offering Level 4 services in cities like San Francisco, Phoenix, and Wuhan. These vehicles are restricted to carefully mapped zones where every lane, every traffic sign, and every obstacle has been cataloged. But within those zones, the cars operate autonomously, and you don't need to touch the wheel. This is where the real magic happens. So, what does this mean for you? In 2025, your personal driveway is still Level 2 territory, but those city centers 5 miles down the road, They could already be robo-taxi land, with autonomous vehicles running the streets. The future isn't fully here yet, but it's already arriving in pockets, and those pockets are growing fast. Safety and redundancy. The hidden wiring. All this advanced computing power raises a natural question. What happens if something breaks? This is where redundancy comes in. In 2025, autonomous cars are designed with an obsessive level of backup systems. Dual electrical loops, dual batteries, and a dedicated watchdog microcontroller that monitors the performance of the AI. If the system detects any anomalies, it can reboot instantly. This ensures the car keeps running smoothly, even if a component fails. This isn't just nice to have, it's a crucial safety measure. Cost reality check. Will your wallet feel it? Let's talk about cost. Will this incredible technology break the bank? Yes, at first. But not for long. While the hardware costs are higher initially, the price gap will shrink as technology improves. In fact, analysts predict that by 2027, the premium for autonomous tech will largely disappear. So, while the upfront cost might be a bit higher, the long-term value is undeniable. Global race. Who ships first? The global race for autonomy isn't just a technological one, it's a geopolitical sprint. China, Europe, and the US are all moving at different paces, with China leading the charge. Countries are pushing forward with regulations to get autonomous cars on the road as quickly and safely as possible. The human factor. Do we trust it? The real question isn't about the technology, it's about trust. Do we, as passengers, trust these machines? Public trust in autonomous vehicles is rising, and as more people experience them firsthand, that fear factor will continue to decline. Jobs and ethics. The awkward questions. The rise of autonomous vehicles also forces us to confront uncomfortable questions about jobs and ethics. While some jobs will be replaced, new ones will emerge, particularly in telesupervision and fleet management. And when it comes to ethics, the real question isn't about the trolley problem. It's about speed and deployment. Do we wait for perfect autonomy, or do we deploy the technology now and save lives? What's next? After 2025, my predictions. Looking ahead, expect V2X communication to become mainstream by 2026, making traffic flow smoother than ever before. Solid-state batteries will revolutionize EV ranges, and subscription-based mobility models will take off. By 2030, steering wheels will become a thing of the past as we fully embrace autonomous driving. So there you have it. The breakthroughs in AI, sensors, and software are transforming our cars from machines that drive into machines that think. The future is now, and it's about to change everything. If you found this as fascinating as I did, hit that subscribe button, and let's keep exploring the future together. Thanks for watching, stay safe, and remember, whether you're driving or not, the future is here.